Hey, well, I'd like to thank everybody for hanging in there for the end of this session. And I want to talk about vaccines. And as we've heard the first speaker, and also you've been hearing over the last couple of days and reading in the media, the response that we've been using to make the egg-based vaccines for the last 50 years has been more or less sufficient, but it's really not going to be sufficient for this pandemic or future pandemics. And you may hear words being, numbers being thrown around like we're going to make 4 billion doses and this kind of thing. But the reality is it's just going to be very difficult to achieve that in any kind of reasonable time frame. So what I'd like to talk about is novel peptide H1N1 swine origin influenza vaccines that we're working on that are synthetic peptides. The important thing again here is this is completely synthetic. These are synthetic molecules that can be made by chemical synthesis. You can make hundreds of kilograms or tons of doses. So you could literally make billions of doses in a very short amount of time, I think like a month or so. So we have, like a lot of other companies, in addition to working on infectious diseases, we also work on cancer vaccines. So why is H1 more lethal than the seasonal H1N1? So there's been sort of a lot of debate. In some countries, it's more lethal, for example, in Mexico than it is in the United States. It could be due to a number of different factors, but it clearly is more lethal than the standard seasonal strain, both in animals, both in humans and in animals. The ferret is used and the mouse are used commonly for animal models. So the seasonal flu infection in humans is usually limited to the respiratory tract, and causes, but the swine origin virus causes a number of unusual symptoms, including vomiting and diarrhea in about 45% of people, indicating that it probably is not confined to the respiratory tract, and also low white blood cell count that's unlike what's seen with the seasonal flu. The low white cell count also happens with H5N1. It may be part of its pathogenesis. We don't know. There's a lot that needs to still be learned about the pathogenicity of H1N1 and H5N1. The swine origin infectious virus, H1N1, causes more severe disease in ferrets. As I mentioned, ferrets are a very reliable model for human infection with flu. It includes mild to moderate necrotizing rhinitis, tracheitis, bronchitis, and bronchiolitis. Basically, it causes more lung damage than the standard flu. And death in animals or in people occurs through progressive pulmonary failure. So our pandemic flu program goal is to develop a novel synthetic next-generation vaccine that's not dependent on eggs or cell culture-based technology that can be mass-produced utilizing existing technology. So like I said, we've had this vaccine technology around for 50 years of growing the virus in embryonated chicken eggs, and it's a crude process, it's a biological process, it's worked, and what the FDA and other countries they keep going back to it because it works. They say, well, we have the egg-based vaccine, it works. But these all have limitations, and really the fastest way to generate a new vaccine for like a pandemic that's going on now is through synthetic peptides. So so that's our idea, is to develop a next generation synthetic vaccine, and this vaccine will be designed to prevent infection and or limit the severity of H1N1 infection in humans. And most of you probably know that in 1918 we had a similar scenario where there's a mild H1N1 flu-like illness that came around the springtime, but something changed during the year, and when it came back in the fall it killed somewhere between 20 and 40 million people. Hopefully that won't happen with this virus, but nobody can tell. The influenza virus is the most highly mutable form of virus that anyone we have any kind of experience dealing with. It can mutate, and all of the experts can say is that in the fall you can just expect to be surprised. It might be a milder virus, but it might be a more severe virus. As you know, H1N1, the swine origin virus, is now in countries like Indonesia where H5N1 is also present. And one of the things that can happen with influenza viruses is they can recombine and you can suddenly get a new virus. So instead of having a virus that kills 1% or less than 1% of people as the H1N1, you might have a highly transmissible virus that kills 50 or 60% of people in a worst case scenario. And so, but in order to prepare for that, we have to be able to develop new ways to respond more rapidly. Methods have become available recently where you can in vitro screen hundreds of peptides against 7 or 8 of the most common DR alleles and try to identify peptides. We hope 3 or 4 that will give broad protection to a broad population. Once again, these are synthetic, they're pure, there's no egg or no any kind of contaminating material in there except for the synthetic peptides, and they can be dried, they can be freeze-dried, like coffee, reconstituted in other places, resource-poor areas in the world, Africa, South America, some places where they don't have as good access to health care. So these things are immunogenic in people, and they may be protective. We just completed one trial in Lebanon, but we also hope to do additional studies in Europe, and also we filed a pre-IND with the FDA for conducting trials in the United States. The advantage over the egg-based or cell culture vaccines that these biological methods of flu vaccine production are finitely scalable, and the production of billions of doses will be very challenging. And you probably already heard some reports coming out from the vaccine manufacturers that are saying they're not making as much vaccine as they thought they were. Only 33% of the vaccine for the United States is being manufactured in the United States. Most of it is being made outside of the country. And countries like Sanofi, who are behind in their production capacity, and they've admitted they're not meeting their deadlines. They've already stated they're not going to give out vaccine until they have enough vaccine for France and other contracts. So there are going to be supply issues. There is going to be scarcity of vaccine. Even in the rich countries, in the United States, it's going to be a problem. And as I said before, and as our first speaker mentioned, large-scale chemical synthesis capacity exists to produce billions of doses of vaccine in a shorter period of time. As you know, these viruses can mutate also. The virus that's circulating now might be totally different from what's going on in the fall. We won't have 6 months or 9 months to prepare for the new virus. As we have used the other method, we need something that's rapid and flexible, and you can make billions of doses in a short period of time. And like I said, chemical synthesis is more rapid and flexible to genetic changes and pandemic flu strains that are highly likely to occur, as this virus did and as future viruses will happen. So I'd like to thank the organizers, and I'd like to thank you for your attention, and I just want to make the main point that we really need to start thinking about novel vaccines for addressing things like pandemic flu and other viruses that are emerging.
Give a hand to our speakers once again. So we want to make sure we go on to lunch.